So the question says that let's say there is a linked list 10, 20, 30, 40, 50, and what I want to do is I want to find the middle point of a linked list. So which node is the middle point over here? That is 30. Okay, so I want to return this 30. How will you solve this question? Let's say you are seeing it for the first time, or your interviewer asked it, you never did before. What will be your first approach? Yes, first you will count the number of nodes. Very good. And after counting the number of nodes, you can easily solve this question. So you count the number of nodes over here while performing your traversal, and that count comes out to be 5. Now basically you need to come at count by 2 if you want to come over there. So basically, you know, count by 2 plus 1 you can, right? So the number of hops that you need to take is count by 2. This is if you take 2 hops, then you will be here. So this is one way in which you can solve it. Even if, let's say, the number of nodes were even, let's say you had 10, 20, 30, 40, 50, 60. Can you tell me what would you print here? So you can either print 30 and you can also print 40, because in such a kind of case where number of nodes is even, there is no one center, there are 2 centers. So you have the flexibility to either print 30 or print 40. I do not worry about that. So even in this case, that approach is going to work, because here your count will be 6, and if you take 3 hops, 1, 2, 3, then you will be at 40. Okay, and that would be your answer. Cool. So can somebody quickly tell the time complexity of this approach? So this is order of n. But did you realize one thing, that there are 2 for loops, although those 2 for loops are independent, but there are 2 for loops. So first for loop, which is supposed to create this count, and second for loop, which is supposed to travel till mid. So do you see those 2 for loops coming up? You see them coming up, right? Can I do it in a single for loop? So there is a very well known way for this. And again, this is a very interview specific thing, interview cliche thing. Let us learn that. Let us learn it in this way, okay? Let's say you and your friend are standing over here. So you and your friend are standing over here, and this is the start point and this is the end point, okay? Now the thing is that somebody asks you that, hey, you have to tell me the middle point. You have to tell me the middle point. Both of you do not know that what is the length of this. What is the length of this channel? You don't know. So what will you do to ensure that you somehow get to know about this? See, one way to get to know about this middle point is that you traverse, measure the length, and then again come back. Okay? But can you do it in one go? Can you find the center in one go? How many of you can find the center in one go? So what will you do? So the strategy that you can adopt is, you will tell your friend that, hey, I am going to move with let's say 1 km per hour, and you move with 2 km per hour. So this guy is going to move with twice the speed of this. Can you tell me, by the moment this guy reaches here, where would this guy be? Because the speed of this is the half of the speed of this guy, so he would definitely be here. So this guy can tell him that, hey, the moment you reach at the end, just give me a phone call and I'll stop there. That means wherever I stop, that is the middle point. So this is the way that I can adopt to solve this problem. So the 2 guys over here are nothing but 2 pointers, and because one pointer is fast, I'm going to call it fast, and the other pointer is slow, I'm going to call it slow. How is slow going to change? Slow is going to change in this manner. It is going to slow equals to slow next. And for fast, it is going to be fast next next. And by the time fast reaches the end, wherever slow will be, that would be the center of the linked list. So this is a very, very well known problem, and all of us should know how to easily solve this. Guys, I'll tell you one thing. With respect to linked list, there are not many varieties. I mean, there are just certain things which I can tell you all. The most important thing with respect to linked list is coding. The companies ask questions on linked list because they want to check your coding skills, how fast you can code and how fast you can write the actual running code without any bug in it. So companies like Amazon and Microsoft especially, they ask a lot of questions on linked list and trees. So coding here is going to be very important. Your interviewer will not settle for approach, that is guaranteed, because he knows that everyone knows the approach. Cool. So if I have to code it, I am going to have a while loop with some condition in it, and then every time what I am going to do is I am going to move my slow by 1 unit and fast by 2 units. Guys, I sense some trouble over here. If I do not have some check over here, my slow might become null and I can get a null pointer over here. Similarly, my fast can also become null. So is it not needed for me to have a check over here? Yes or no? Don't you think so? I need to have a check over there, right? So can you tell me what check should I have? Tell me one thing, that's a common sense that I am asking. If I just ensure that fast is not null, if I just ensure that fast is not null, will it automatically ensure that slow is also not null? It will. Why? Because fast pointer will always be ahead of the slow pointer. So because your fast pointer will always be ahead of slow pointer, so you can just have a check that while my fast is not equals to null. Now if this condition is obeyed, then this will never be null and this is safe. So I am good. And if this condition is obeyed, so null pointer cannot happen here also because of this. But what if this thing is null? Can it not happen? Can it not happen that fast next becomes null? It can happen, right? So the checks that you need to have are while fast not null and fast next not null. Till then you would want to do this thing. And by the time this loop is broken, then whatever your slow will be, that will be your mid. So the final thing that you would do is to return the slow. Now let me ask you one question. If let's say, because there are two conditions over here, so this loop can break either because of this being false, or the loop can break because of this being false. If the number of nodes are odd, which of these two conditions, A or B, which of these two conditions will make the loop break if the number of nodes is odd? Please take your pen and paper out and just take an example of odd number of nodes and see that which of these two conditions is getting this loop to be broken. It's B, right? It's B, because what is happening is, let's say you have 10, 20, 30, 40 and 50. So you had your fast and slow here. Now your fast came here and slow came here. Now your fast came here and slow came here. Now don't you think so that when fast is here, fast next will be null and you will return this value of slow? So when the number of nodes is odd, then I am getting correct answer, because when it is at end, it is here. But what if the number of nodes is even? So if the number of nodes is even, again you had a slow here, fast here, the slow came here, fast came here, the slow came here, fast came here, then your slow came here and your fast became null. So even here my answer is correct, because I had told you before that in case of even number of elements, there are two centers, and whether you answer me this or answer me this, I am perfectly okay with that. Now my code is customized in such a way that for odd number of nodes, it will always give me the actual center, and for even number of nodes, it will give me second center. Center 1 and center 2, it will always give me second center, because it is not terminating here, rather it is terminating here. So guys, I have done many things over here. First thing is that I did not just blindly write it. I put a safety check over here. Now sometimes what might happen is that because of the safety check that you have, the correctness of your algorithm might be getting compromised, because certain times it is ending at the end and certain times it is ending at the end of the end. So that you have to manually check. If you are able to check that, hey, it is all going to work, then only you can say that, hey, the code is safe as well as correct. So these two things, both of them are important. It should be safe. By safety I mean null safety, and at the same time correct. Okay. Now let us think that if I have change this question a bit for you. I'm asking you to tell me the node which is at 1/3 the distance. So let's say this is 1, 2, 3, 4, 5, 6. So I want you to tell me this node, because this is at 1/3 the distance, which is 6. How will you be able to do this problem? So previously you were telling me the node which is at half of the distance from beginning, and now I am asking you for the node which is 1/3 the distance from the beginning. How can I do that? Yeah, so here what will you do? Again the same logic. First pointer will move with 1 speed and second will move with 3 speed. So by the time first one reaches end, the second one will be at distance d by 3. Okay, but do you see that in that case this as well as this condition, so basically the conditions over here will change. So there will be 3 ands. So please ensure those things whenever you see a new problem. Okay.